Today we will study about our new chapter, Force and Laws of Motion. In our everyday life, we observe that some efforts are required to put a stationary object into motion or to stop a moving object. We ordinarily experience this as a muscular effort and say that we must push, hit, or pull on an object to change its state of motion. The concept of force is based on this pull or push. So, force is any action which causes push or pull on a body is called force. Any action which causes push or pull on a body is called force. Force cannot be seen, but it can be judged only by the effects which it produces in various bodies around us. So, many effects of force are as given below. First effect, a force can move a stationary object. If this is any stationary object, a pen, and if we apply force on this pen, then force can move this stationary object. If I apply force on this pen, then because of force, pen can move. Second effect, a force can stop a moving body. If there is a moving body and we apply force on that moving body, then we can stop that moving body. If pen is a moving body and pen move from here to here and we apply force in front of this pen, then we can stop this pen. Third, a force can change the direction and speed of a moving body. A force can change the direction. With the help of force, we can change the direction of a body and we can increase or decrease the speed of any moving body. Fourth, a force can change the shape and size of a body. With the help of force, we can change shape and size of any body. If we have a rubber ball and we apply force on that ball, we compress that ball, then we can change shape and size of that body. Forces are of two types, such as balanced forces and unbalanced forces, which are as given below. Balanced forces. When the net effect produced by a number of force more than one force acting on a body is zero, then the forces are said to be balanced force. If there is any body and we apply more than one force on that body, but if effect on this body is zero, net effect is zero, then the forces are said to be balanced force. If this is pen, if this is cap of pen and we apply more than one force on this pen initially in its stationary position, it is not moving, and if we apply so many force on this pen from here and from here, I apply two force on this pen. First force from here and second force from here. But if the net force we apply, the net effect of force I apply on this pen is zero, then pen does not move. That type of force are known as balanced force. Second is unbalanced force. When the net effect produced by a number of forces acting on a body is non-zero, then the forces are said to be unbalanced force. If this is pen and I apply so many forces on this pen, one forces or more than one forces, and the net effect of forces is not zero, then pen move. Then this type of force, if this cap of pen changes its state, then this type of force is known as unbalanced force. In balanced force, object do not change its position. In balanced force, the net effect of force is zero, so object or body do not change its state. In unbalanced force, the net effect of forces is non-zero, so object or any body change its state. Newton's laws of motion. Newton studied the ideas of the motion of an object. He formulated three fundamental laws that govern the motion of object. These three laws are known as Newton's law of motion, which are given as number 1, Newton's first law of motion. It states that an object will continue to remain in its state of rest or of uniform motion along a straight line path unless an external force acts on it. This means all objects resist change in their state. The state of any object can be changed by applying external force only. Newton's first law of motion. If any object is at rest, state of rest, and we apply force on that object, then that object resists change in their state. Object resist change in their state. If object is in motion and we apply force on that object, then object also resists change in their motion. So according to Newton's first law of motion, all objects resist change in their state. Example: a person standing in a bus falls backward when the bus is started moving suddenly. This happened because the person and bus both are in rest. While the person is not moving and bus start moving, the legs of the person start moving along with bus, but the rest portion of his body has tendency to remain in rest. Because of this, person falls backward if he is not alert. Another example: a person standing in a moving bus falls forward if drivers apply brakes suddenly. Inertia. Inertia is the inability or unwillingness of an object to change its state of rest or of uniform motion is called inertia of the object. Newton's first law of motion, also known as inertia of any object. All objects resist change in their state. It is the inherent property of all the objects. Inertia of an object is measured by its mass. Inertia is directly proportional to the mass. Inertia depends on mass. It means that inertia increases with increase in mass and decreases with decrease in mass. A heavy object will have more inertia than lighter one. A heavy object have more inertia than lighter one. If we have an object of mass 50 kg and the object is at position of rest and we want to move that object, and we know according to Newton's first law of motion all objects resist change in their state. We want to change state of object from rest to motion. Then we need more and more force to move that object because mass of that object is 50 kg. If there is another object and mass of that object is 1 kg, mass of that object is lighter than 50 kg. So we know that inertia depends on mass. So we apply very few force to move that object. So we can say inertia is directly proportional to mass. A heavy object will have more inertia than lighter object. Question number 1. Which has more inertia? Option number first and option number second. Solve these two questions.